Welcome back. In this video, we're going to talk about prop collision. And in order to have prop collision, we're going to need collision rectangles from both the prop and the character. This way we can check to see if they're colliding. We're also going to create an array of props, so it'll be easier to loop through the props and check for collisions. Let's get started. So here we are in the main function. And we're creating a prop and calling it rock. And then we go down into the while loop and we're calling render on that single prop called rock. Now this would be a lot more convenient if we had an array of props instead of a single prop called rock. So we're going to create an array. And this will be an array that holds props. So we're going to say prop and call this props. And at first, we'll just start off with two elements in the array. And we'll use braced initialization here to add some elements here. And we need two elements. So what I'd like to do is use the prop constructor. So we're going to say prop followed with braces. And here in the braces, we're just going to copy what we previously used to initialize the rock variable. So let's paste that in, and it's basically a vector2 with 0, 0, and we're loading the rock texture. Now, as we saw, putting the rock at 0, 0 places it way out into the water, and our character can't go that far. So let's bring the rock inland a little bit. So I'm going to put this at 600 and 300. Now we also need a second element in the array as we made the array of size 2. So I'm going to put a comma, and for the second prop, I'm just going to copy the first line and change the location. So the location for this one will be 400 and 500. And instead of the rock, I'd like to draw something else. Let's use log.png, so our second array element will be a log. Now we no longer need this rock variable, so I'm going to go ahead and delete it. And we need to scroll down to where we're calling render. And instead of calling render on the rock variable, which doesn't exist anymore, we can loop through the array. So take a second to think about how we're going to loop through this props array and call render on each prop. Okay, so we're going to use a for loop, and we can use a range-based for loop by saying auto prop props. This means we're going to loop through the props array, and for each prop in that props array, we can do something. And of course, the compiler is going to deduce the type for prop to be the prop class. So in the for loop, all that we want to do is simply call prop.render. And for render, we need the knight's world position, so we can pass in knight.getWorldPos. And that's it. Now, if we go to run and start debugging, then we can run down and see the log and the rock at the locations that we set them to be in. And all looks great. So we're going to put a comment here and say, draw the props. So that way, as we add more props, all we need to do is change the size of the props array and add more elements to it. Okay, so now we have multiple props. Now let's think about collision with those props. In order to check for collisions with a prop, we need the prop's screen position. That's going to involve an X and a Y for the location of the rock on the screen. We're also going to need the rock's width and height, which is going to involve that scale variable as we're drawing the rock at a scale that's different than the size of the texture itself. So why don't we create a function that will return a rectangle that has this information? So here in prop.h, we can create a public function that returns a rectangle. And we're going to call this getCollisionRec. Now, since this involves the screen position, it's going to require the knight position, as the screen position of a prop depends on the knight position. So let's go ahead and define this function. We'll go into prop.cpp just under the render function, and we'll fully qualify the function name using prop with the scope resolution operator. Now here in getCollisionRec, we need to calculate the prop's screen position. So we can create a local vector 2 called screen pause, just like we did in render. And this uses the world pause of the prop and the world pause of the night. And after performing vector 2 subtract, we have the screen pause for the prop. So we can copy this line and paste it here in Get Collision Rec. Now we need to return a rectangle. So we're going to return rectangle, and we'll initialize this rectangle with some values. The x and y are the screen pause x and y. So we're going to use screen pause.x for the x, screen pause.y for the y, and next we need the width and the height, and those will come from the texture. So we're going to say texture.width, and we need to multiply this by the scale. Same with the height. It's going to be texture.height times scale. And I'll place the semicolon here, and now we have a function that returns the rectangle that represents the collision rectangle for the prop. It's a rectangle at screen pause with a width and height equal to the dimensions at which we're drawing the prop. Now we're going to need a collision rectangle for the character as well. And this will, of course, involve the character's screen position, that involves an x and a y, and also the width and height of the texture we're drawing to the screen, and of course that means it's going to involve the scale as well. So let's create a function to return the character's collision rec as well. So here in character.h, this is going to return a rectangle, and we'll call this getCollisionRec. And we can define this here in character.cpp. So I'll go down to just under the undo movement function, and we'll create the function body, and we won't forget to fully qualify the function name. Now for the character's getCollisionRec, all we need to do is return a rectangle. Now take a second to fill out this rectangle with the correct information. Okay, so the rectangles x and y are going to be for the character's screen position. So this is going to be screenPause.x for the x and screenPause.y for the y. And the width and height are going to be the character's width and height scaled by the scale variable. So this will be width scale and height scale. There's our semicolon, and now we have a getCollisionRec function for the character. So now that we have functions that can return collision rectangles for both the character and for the prop, here in the main function, we're going to want to check those collision rectangles. So down here where we're checking the map bounds, if we're hitting the map bounds, we undo the knight's movement. Just below this would be the perfect place to check to see if we're colliding with props. So here's your challenge. You're going to check for prop collisions. In the while loop, just after checking the map bounds, loop through the props array and use checkCollisionRecs, the built-in raylib function that takes two rectangles as arguments. You're going to call getCollisionRec on both the prop and the knight to get those collision rectangles to pass in to checkCollisionRecs. Then call undo movement on the knight if there's a collision. Keyword if. Pause the video and do this now. Okay, so just under checking the map bounds, we're going to loop through the array. So we're going to say for, and again, we'll use a range-based for loop. So auto prop in props. Now we're going to check for collisions. So we're going to use the raylib function checkCollisionRecs. Now first we'll use the prop collision rec. So we're going to say prop.getCollisionRec. And again, the prop getCollisionRec function requires the knight position, so we're going to use knight.getWorldPause. For the second argument, we're simply going to call knight.getCollisionRec. I'll go ahead and move the sidebar so we can see what we're doing. So we have this call to check collision recs. We're going to use this as the conditional for an if check. So we'll say if, and we'll place this call to check collision recs in the parentheses for the conditional, And we'll reach the inside of the if statement if check collision rex returns true. And that will be the case if there's a collision between the character and a prop. So if that's the case, we're going to call knight.undoMovement. And we'll put a comment here saying check prop collisions. And it's as simple as that. Let's go ahead and hit run and start debugging. So we can go and find these props, and they're right here. And we can simply try to run into the rock, and we'll see that we're blocked by the rock because we're getting a collision and calling undoMovement each frame to undo the knight's movement. Perfect. So in summary, we handled prop collision by creating a props array so that it's easier to loop through each prop, and then we get the collision rectangles for the prop and for the character and call checkCollisionRex, the built-in raylib function designed for checking two rectangles to see if they're colliding with one another. And in the event of a collision, we simply call undoMovement for the character. Now we have props that can actually block the character from moving through them. Great job. I'll see you in the next video.